Oh, g'day, champions! I don't know what it is with Gallien, Krueger, and the RB series, but they're one of the most abused amps in the world, in my experience. Let's show you the typical things they come in with. So this one is a 400 RB. It's the single channel, no internal crossover, no active crossover like the 800 RB. It's only 200 watts into 4 ohms on the output, but they're just workhorse amps that just seem to not die. And this one, despite the previous tech's best efforts, was still producing signal, more or less. So this owner understands the worth of these things and how they just keep on kicking. So they're great backup amps. If all else fails, this one will always back you up. So first things first, it's still got the original electrolytic caps, sorry. So they're going to get replaced with some 105-degree V-shays for long life. Now here, someone's replaced a emitter resistor. Now the job of the emitter resistors is to balance the load across the multiple output devices, and well, despite the shitty installation, it's a different value. It's 0.22, the others are 0.33, so straight away the transistor this one's attached to is going to cop more current than the others, so it defeats the purpose of having a emitter resistor at all. And down underneath you can see where that's the speaker outlet, where they're all connected in common. The other end's connected to the emitter of each of the output devices. In this case, MJ, it's the complementary MJ15001 and MJ15002 complementary pairs. This one has had enough slack on the leads that it's been able to touch at some point, and the amount of current that's available there, you can see it's blown a bit of a hole in the alley there, which is pretty impressive. They've left half of the old resistor behind, which is just ridiculous. Maybe that was actually them trying to dig away that resistor. That's probably more likely, but it can still touch it. That's touching there, and that's not good. That's your speaker, like shorting out your speaker, so that would blow up your output devices as well. So they've crushed the old resistor and said fuck it and just install a new one over the top of the wrong value. It's pretty standard fare for the techs around here that I've seen the aftermath of their swindling, I guess you could say. You got things like here's a wire coming from the board here. That's the direct out wire carrying the signal to the line out, essentially. They've passed it through the jack. Like, come on, man. Like, that's just... a 2-year-old would do a better job of that. Like, and you can tell it's not... like, it wasn't by accident, because it's held captive in there by that wire. So, I don't know, you probably... if you put that one over there and put this one over here and then thread that one through there, maybe that's how they meant for it. But, you know, that's not... and they've got a clamp there, so... I don't know, that's pretty shitty. The whole front board where the pots are is just covered with this grime and slime from using way too much cleaner on the pots, and it's got a weird smell to it too. So I've tested it. I have turned it on, and the pots aren't too bad. But I'm going to be taking that board off, washing whatever the hell that is, because you can see everything's just sticking to it down in there. There's just like dust. That's probably from, yeah, well, there's the screw hole. So because they've used the wrong screws, which I'll show you in a sec, it's stripped the hole, so all the powder coating and aluminium residues ended up where it would, directly underneath it, gravity, on the board there, and then stuck to that slimy residue that's on the board. So it's just a comedy of errors, just thing after thing after thing, all making up for a really shittily serviced amp. But luckily it's here, and I love these things, so we're going to take care of it. You got the usual dirt and schmoo in the heatsink. This is a big ass passive heatsink on the back, no fan on this model. The outer fins are almost always bent in from impact. You can see right there the impact on there, and this end fin was bent in. I bent it back with a piece of metal. But yeah, these heat sinks are not the most efficient, but you don't need a fan, and they just battle on. So it's got the inevitable missing switch cap. Luckily I had one in stock, but GK charged like $12 each for these things or something stupid, because they know it's a weird size and they can do it and get away with it. But another thing that just seems to be an invariable issue on these things, everyone that comes in, someone's just lost all the screws. Like, some tech's just undone it and thrown all the screws in the bin. Like, I just don't get that. Put them in a fucking container. Like, it's not hard. But every one of these comes in with mismatched screws. Like, look, these were the chassis screws. You got 1, 2, 3, 4, 5, like 6 different types of screw, different threads. And you can't just throw a self-tapper into a friggin' machine thread hole. So, as expected, every single hole in this thing is reamed out. If it's not reamed out by too large a screw, it's stripped by over-tensioning a machine screw or incorrect threaded machine screw. These are aftermarket. I haven't seen them before on GK. They're supposed to have rubber. That's just cheap plastic that you find on grandma's coffee table. The only real option now, because all the holes are reamed out, and I've done this to other ones in the past too, because like I say, pretty much all of them have had this happen to them. I put nutserts in those holes. I drill them out to a larger diameter, and then I put a steel threaded insert in there, usually M3, and then I replace all those mismatched screws with some countersunk M3 stainless screws. A little bit of anti-seize on there so it doesn't bind up on the threaded steel insert, being unlike metals. And that will last forever. Well, providing Uncle Grandad doesn't get his impact driver out on it. So as expected, some of these jacks, if the jack itself is okay, the shunting contact is starting to fail. Not such a massive issue for the input. It's just like, if you got nothing plugged in, it might not be as quiet as usual, but you tend not to operate amps with nothing plugged in, really, do you? The biggest issue is that jack down the bottom there. Can you see it? No, because I've got a Panasonic. That there, the contact isn't normaling, so you're getting intermittent signal. Now that's probably the main reason this thing came in, and we discovered all the other horrors, because that little contact down there just corrodes, because often people don't use effects loops on these things, they just plug in and rock, and as a result those contacts don't get cycled that often, and they just get a bit of corrosion on them. So that jack I will replace, and the rest of them I'll clean. But the biggest issue on this amp is I think someone's replaced the power transformer at some point. We've got these heat shrink tubing that's not really shrunk. It was shrunk by a soldering iron barrel, but not hot air like you should. So you can easily pull them back and expose the wiring. But more important than that is there used to be like fish paper, like insulative card essentially on these, and they're on all the others, and that's gone missing as well. So that's like mains voltage. Is it this one? No, I think that was the secondary side. But look at the chaos there, because all they used to insulate was a bit of shitty fiber tape, like the stuff you put around your strapping when you've got a bad ankle or when you play football. I just can't get my head around these other people that, like, if you're doing this to your own amp, stop now, take it to a tech, and don't say we're gatekeeping, because you're gonna fucking kill yourself or someone else, because you don't know what you're doing and you're too proud to admit it. If you're another tech, well, you're not a tech, so put the fucking soldering iron down, go and work at Macca's, you dickhead. But enough doom and gloom. On the bright side, all the knobs are present, which is rare and nice, and all their knobs pointer caps are present, which is even rarer, which is great, because I think the only reseller that I could find them at for another amp was selling the caps themselves for like $18.95 and the knob for like $30, because they're a bunch of price gouging fuckheads and they know that only they have them. So I told them, you know, well, you can imagine what I told him. So you can see the fuse holder there's copped a bit of abuse from some gorilla-like application of torque. I'll probably just replace that fuse holder insert, and the body of the fuse holder itself can remain because it all looks reasonably okay, albeit blurry. Now looking at the bottom of the circuit board, the solder connections are actually not too bad on the pads there, because this is pre-lead-free solder, before they really honed in the lead-free recipe. The early lead-free stuff was really terrible for making good joints. A little bit like me in junior high. Alright, so here's the mains wiring. We can see that they didn't bother replacing the cord from the US style. That gland is really loose. So they've done what a lot of people do, and they think that a cable tie is like, you know, the world's strongest grip, and it really does fuck all, to be honest. But that's American wiring code, so this is not an Australian lead. What they've done is, on the other end, they've just snipped off the plug and just put an Aussie plug on there. So we'll be replacing this whole lot with a proper sized gland there that will actually give some strain relief, and a molded safety plug instead of these stupid things. They go all corroded and stuff. And we'll have the proper Australian standard wiring, which it is on the rest of the wiring down there, blue and brown. So in summary, what are we doing? We're replacing the, let's start from the start, we're replacing the pad button cap. Wow. We're replacing the effects return jack. We're doing a full recap. I'm going to replace all these resistors at once, and we'll put a bunch of wire wound replacements in there. I'll test them for drift, but I'm not a fan of the way they're mounted, and I'm not a fan of this bullshit either. So all of that will be taken off to clean the silicon out, redo it. The transformer, these areas, I'll put some proper fish card there, and I'm going to put it so if you accidentally get the cover around 180, it'll be there and it'll be there on the thing. So if some other boneheaded dickhead tech takes the cover off, or even, you know, if the customer gets curious, takes it off, puts it around 180 degrees around, they'll still be safe. So that's 4 pieces of card, 2 on each cover, 1 for either side, the primary and the secondary. So in addition to that, we're going to take this whole front board out. We're going to clean it off, clean that residue off it. While that's out, I'm going to drill out all these holes. I'm going to put nutserts in them, and I'm going to, when we reassemble it, going to put some stainless countersunk M3 screws in. We're going to give the thing a good old clean, and then we're going to fire it up, take some measurements, and record them all for the customer, because I put that on every invoice as a job sheet. We're also going to replace the cord, replace the cord retention gland down there like we talked about, and replace the fuse insert. Alright champions, all the work's done. I thought I'd save you the dramas. We've cleaned everything up. We've replaced the FX loop jacks. I just replaced both of them because they were long shaft and they had about 1 million washers on them, so I just put the proper bushing length ones in. We've rearranged the wires across here like they were from the factory. I've cleaned up the nappy rash cream as best I can from the previous tech. We've replaced all the emitter resistors there with a match set. A new stack of caps. Eventually we're going to have to start putting radials in these because it just won't be practical or economical to use axials. They just won't be available. But for the moment, I have some in stock and they're still available. So let's put the original sort of spec component in there, or original form factor. We've got like eyelet board material there. I've put a dab of silicone on that transformer, but I've also got some double-sided tape on the inside of that rim there, and that double-sided tape is formidable stuff from 3M. So that is, I've decided against putting it on the lid. It's easier to just have it in place here, and it's still flush with the inside there, so that'll be safe now. Redone the wiring so it goes hot, fuse tip, fuse ring to switch to transformer. It was the other way around before. Just another level of safety there. We've replaced all the other electrodes. Down here we've replaced the electrodes on this board as well. You can see a little Nichicon hiding down there. We've cleaned and re-lubricated all the pots and switches. I've put that missing switch cap on, so that's replaced now. That's cool. I've shortened this ground wire here. It was it had a big loop in it before, so I've just neat and tidied everything up a bit, just, you know, OCD and whatnot. We've got a new cord with a molded safety plug, and when I say safety plug, I'm talking about this here. So see that black plastic insulating at the base of the active and neutral prongs there, live and neutral, you can see the L in the end there. That is so if the plug's half out and something drops down, say it's like hanging out, and this has happened to me, a guitar string has, I've been setting a guitar up and a guitar strings find the most inappropriate shit ever to land on, be it your eyeball or something like this. If it falls in there, it could short out and just big arc flash, or it could just touch one of them and you could go to pick up the guitar string, it could be live. So it's another level of safety there. I think that's Australian standard on all equipment now, that they have to have a safety plug. And down here we've got a thicker cable, so with that existing gland, it's actually tight now, not coming out. On the underside, we just cleaned up all the flux and everything, and touched up any solder joints that looked a little bit suspect, but they're all pretty good. You can see here just under 28 volts at the onset of clipping into 4 ohms RMS, so that works out to about 195 watts into 4 ohms at 1 kilohertz. Despite the marketing department's 400 pasted everywhere, this is a 200 watt amp, and likewise the 800 has one channel at 300 watts and one channel at 100 watts, so 400 watt total. So they're doing the creative power rating thing again. It was a thing. It still is. Now I've had to cut some of the new screws down. The ones in the corner there were going to hit that jack. This one lands like you couldn't have planned it, perfectly between the jacks without touching anything. Some of them, that screw is going to be short enough not to matter, but if you were to use a big long screw there, you'd go straight through the mains cord. So you got to be very careful of that. In the corner here, that's your switch. Main switch with a hole right next to it. Again, that misses, but if you had your mains feeding in on a single pole dual throw switch, there'd be another terminal there, and when it was turned off, that terminal would have mains on it if you fed the mains in to that center pin. So this is all stuff you've got to be cognizant of. It's not a simple matter of just changing screws out. That's how you can become unstuck. The 800 series has a big bridge rectifier on the other side of the board here, and if you drive your screws straight in, even a moderately short one, it's going to short out your AC connection and give you a dead short to ground. You're wondering why you're blowing fuses as soon as you power the thing on. Ask me how I know. Now, it always seems like a good idea to use stainless screws because they look pretty forever, but when you're using unlike metals, or even stainless into stainless, it can cold weld, and that means galling up your screw thread, destroying your screw thread in the hole, and possibly snapping off a screw, trying to get it back out again. It is insane how firm some of them can weld themselves in a fraction of a second, to the point where you're like, hang on, this has got to be a blind hole, and it's not. It's just welded itself. So I use a tiny dab of this copper anti-seize. You don't need much, just a tiny bit on the tip of the screw, and it finds its way into the thread, and that prevents that from happening. You only buy this because you've learned the lesson. I know none of you are going to buy it, but when you learn the lesson, that's when you'll buy it. Alright, so there we are, all new Staino screws installed, nice and flush. Lots of, you know, road cred, street cred scratches there, but she's all secure now, and all uniform screws, same thread as the original. So she's back in one piece again, sound tested, it's sounding great. I'm not going to do a sound sample on this because it just sounds like a GK400RB, which is clean, strong power, albeit only 200 watts, but great sounding modern sort of voiced amps. I've got another few more coming up soon, so I might do some sound samples for them, but in the meantime you can just use your imagination and listen to every recording known to man in the 90s, and that's, you're probably hearing one of these or the 800. You know, that pressed in was the sound of the 90s pretty much, with both the neck and the bridge pick up on it simultaneously. And you can set the EQ flat and you're in 90s bass tone town. Oh, and I put some new rubber feet on there too, and they've got little washers inside them just to prevent any rattling from these hard plastic ones that it came in with. A little bit of shock absorption there. So I'll leave it here on this one, champions. It's just good to reverse all this hack work. It feels really good to make a amp nice and solid again. So I'll see you on the next one. Legends!